All right. Welcome to A1 Tutor Live class. Welcome to the mathematics section of A1 Tutor Live class. So if you are online and you can hear me, you can as well see the screen. Please kindly signify. If you are online and you can hear me, and as well you can see the screen, please kindly signify. Yeah, if you can hear me, please kindly signify. I need your reactions. All right, okay. Okay, so welcome back once again. This week we have been treating a topic. We started last week and we continued on Tuesday, on Wednesday, right? So today we want to round it up. That is the topic indices, logarithm, and surd. Yesterday also we did the continuation of this topic, and today we'll be rounding up the topic indices, logarithm, and surd. So in the previous classes, we've been able to discuss the laws of indices, also the laws of logarithm and surd, which we discussed yesterday. So today we are majorly going to be focusing on solving questions using those laws. We'll be solving UTME question using the law we've discussed in the previous classes. Okay, so if you are with me, we are going to start now with the first question. We're going to start with the first question, a UTME question, to brush through what we've discussed earlier. Okay, so we're going to consider questions under indices, question under logarithm, and also surd. And I will need our full attention as we start solving those questions. So application 1, we asked to simplify without using tables. A UTME question 2018, and the question is 2 root 14 times 3 root 21 over 7 root 24 times 2 root 98. 2 root 98. So that's what we want to simplify. Solution. I believe you are with me and you can hear me properly. Please kindly signify in the chat box as we're about to start this question, so I'll be sure that you are following. I need your reply in the chat box if you can hear me properly and you can see what I have on the screen. Please just type yes in the chat box so we can proceed. I'm waiting. Just type yes in the chat box so we can proceed. Waiting for your response. Are you with me? Please let me be sure so we can start the solving for this question. Still waiting for your reply. All right, can I proceed with the solving? Okay, let's proceed. So we are asked to solve this question. Simplify without using table. 2 root 14 multiplied by 3 root 27 all over 7 root 24 multiplied by 2 root 98. So it's a UTME question, 2018. So we are going to solve this together. 2 root 14 multiplied by 3 root 21 all over 7 root 24 multiplied by 2 root 98. So for us to solve this, we need to simplify each of the roots we are given in the question. Each of these roots, we need to simplify it. Okay, so to do that, let's consider the first root, that's root 14. Root 14 also is expressed as root 2 times root 7. You know, we said one of the law of sort is that root A times root B is equals to root AB. We discussed that in our previous class. So root 14 can also be expressed as root 2 times root 7. Okay, now let's take 21 now. Root 21 is also expressed as root 3 times root 7. Okay, root 3 times root 7. Okay, what of root 24? It is also expressed as root 4 times root 6. Root 4 times root 6. Okay, when we proceed, we have root 98, which we express as root 2 times root 49. Root 2 times root 49. So all these we are going to substitute into what we have here. So we have now 2 times root 14 has been expressed as root 2 times root 7. So that is root 2 times root 7 multiplied by 3, this 3 value, this 3 we have here, times root 21 is root 7 times root 3 times root 7. So root 21 now is root 3 times root 7, all divided by 7 multiplied by root 24 is root 4 times root 6, root 4 times root 6 multiplied by 2 times root 98 is root 2 times root 49. Root 2 times root 49. Okay, so I'm going to continue here. So with this expression we go ahead to simplify the more. 2 multiplied by root 2. Of course, root 2 does not have a perfect root. Times root 7 also. Times 3 times root 3 times root 7. So root 7 does not have a perfect root. Root 3 also does not have a perfect root. So we have it as it is. No need of writing it in decimal. It has to be in short form. So we have 7 here. The square root of 4 is 2. So that would be times 2 times the root of 6, because 6 also does not have a perfect root, times 2, and here times 2 again times root 2 multiplied by the square root of 49 is 7. So we have 7 here. 7. Okay, so when you check the numerator and the denominator, there are some of the value that can actually divide themselves. But before we go and do that, let's express this root 6 also to be, this root 6 can also be expressed as root 2 times root 3. So I want to express that also. 2 root 2 times root 7 times 3 times root 3 multiplied by root 7 all over. Here we have 7 times 2 times root 6 is also root 2 times root 3. So we've changed root 6 to what? Root 2 times root 3 times 2 times root 2 times 7. Now we can proceed to do some division. Okay, so root 2 here can cancel root 2 out. Okay, we have root 3 also here, can cancel out root 3. Okay, so we are left with 2 times root 7 multiplied by 3 times root 7 all over 7 times 2, okay, times what we have here is 2. This is 2. So 7 times 2, then times 2 again, multiplied by root 2 times 7. So when you simplify this, you have 2 times 3 will give us 6. If I multiply 2 times 3, I will have 6. Okay? And root 7 times root 7 is going to be what? 7 over. Here we are going to have 7 times 7, that is 49. But let's just write it as 7 times 7. Okay? Multiply by 2 times 2, that is 4. Okay? Multiply by root 2. So here also we can say that 7 will cancel out 7. 7 cancel out 7. Okay? So here, 2 here, 2, 2 here, 3. Okay, so we are left with a particular value. We are going to have that here. Let's write it here. Permit me to clean this place so we can continue from this part of the screen. Okay, all right, let's proceed. So we have left here, what we have is 3 times 1, because we've cut out the value already. This is ordinary 1 here. And at the denominator, we have 2, we have 7, we have 2, and we have square root of what? 2. So we have that to be equal to 3 over. At the denominator, we have 7 times 2 times root 2, which is going to give us 3 over 2 times 7 is 14 root 2. 14 root 2. So this is going to be the final answer. 3 over 14 root 2. 3 over 14 root 2 will be the final expression. If you decide to rationalize, you can go ahead to rationalize it, and you're going to have a different response. If I say 3 over 14 root 2 times root 2 over root 2. That is rationalization. I'm going to have 3 root 2 over root 2 times root 2 is 2. 2 times 14 is what? 28. So we can also have this as the final answer by rationalizing. By rationalizing this value that we had initially. When you rationalize 3 over 14 root 2, you are going to have 3 root 2 over 28. 3 root 2 over 28. Okay, I believe this question is clear to us. If the solvings are clear to you, please respond in the chat box. Waiting for our response. If the question is clear to us, the solution is clear to you, please respond in the chat box. Is the first application, is it clear to us so we can proceed to the next application? Waiting for your reply so I can go on with the next application. Any question based on the first application? Any question on app 1? Any question? Okay, if we don't have any question, let's proceed to the second application. So permit me to clean the board. So app 2. App 2. So we are going to take a question on logarithm this time around without table. Evaluate log 4 base 2 plus log 2 base 4 minus log 5 base 25. This is UTME question 2016. So let's solve this together. Solution. So we want to consider now a question under logarithm, and that question is from UTME 2016. Okay, we are asked to solve or to evaluate without using table. So we need to simplify until we get the final answer. So we have log 4 base 2 plus log 2 base 4 minus log 5 base 25. So to do this, we need to express 4 in terms of the base. The base here is 2, so I want to express 4 in terms of the base, and that means 4 will now be equals to 2 raised to power 2. So I can have the same thing with the base. And for this one, log 2 base 4, the base is 4. We can also express the base in terms of what we have here, which is this 2. So this 4 also, the 4 at the base will be also equals to 2 raised to power 2. And for 25, we are going to have 5 raised to power 2. Okay, 5 raised to power 2. So we are going to substitute that in this expression. Log 4 That will be 2 raised to power 2 base 2 plus the base here we change to 2 raised to power 2. That's the base. It was 4 before, but now is expressed as 2 raised to power 2. Then we have the 2 minus log 5. The base was 25, and now we are going to express the base as 5 raised to power 2. Okay, 5 raised to power 2. So from the law of logarithm that we discussed yesterday, we said that if we have log x raised to power n base b, what we have to do is to take this guy to the back of log. That will be n log x base b. So the same thing we are going to apply here. So if I take these 2 to the back of log, I will have 2 log 2 base 2. What about this case? If I have log s base b raised to power n, what are you going to have? You take this guy also to the back, and in this case, it's not going to be n, it's going to be 1 over n log x base b. Okay, so if I take these 2 to the back of log, I will have 1 over 2 log 2 base 2 minus. The same thing applicable to this also. If I take this guy to the back of log, I will have minus 1 over 2, following this rule, minus 1 over 2 log 5 base 5. I believe that is clear. Okay, so yesterday also we made mention of another law that states that log a base a is equals to a value. So if you are with me, can you give me the response? Log a base a equals to what? Log a base a equals to what? Log a base a will be equals to what? That should give us 1. Log a base a will be equals to 1. So for all this expression, log 2 base 2 will be equals to 1 also. So that means we have 2 in brackets. Log 2 base 2 is 1 plus 1 over 2 in brackets. Log 2 base 2 again is what? 1 minus 1 over 2 in brackets. Log 5 base 5 is also equals to 1. So when we multiply out these brackets, 2 times 1 is 2, okay, plus 1 over 2, 1 over 2 multiplied by 1 is 1 over 2, minus 1 over 2 multiplied by 1 is 1 over 2. So 1 over 2 minus 1 over 2, this cancel out this, and the final answer is 2. The final answer is what? 2. So for this question, UTME 2016, the correct option is 2. That is, the answer will be equals to 2. The answer will be equals to 2. If application 2 is clear to us, please, I will need your response in the chat box. If application 2 is clear to us, thumbs up. I need your reaction. Thumbs up, your reaction. All right. Okay, thank you, Abiodun. Okay, let's proceed. That means we can proceed to the next application, right? If we can proceed to the next application, please thumbs up so that we move to app 3. We have a lot of applications to solve today. All right, thank you, Abiodun, for your response. Let's proceed to app 3. App 3, so I'll be cleaning the board. App 3. Okay, at 3. Now we are going to consider a question under indices. A question under indices. We've considered a question on surd. We've considered a question on logarithm. Now we want to consider a question under indices. Okay, so evaluate, open bracket, 343 raised to the power of 1 over 3 multiply by 0.14 raised to power minus 1 multiply by 25 raised to power minus 1 over 2. So this is UTME question also 2016. Let's solve this together. We are asked to evaluate this expression. We have 343 raised to power 1 over 3 times 0.14 raised to power minus 1 times 25 raised to power minus 1 over 2. Okay? Raised to power minus 1 over 2. So let's proceed. From the law of indices, we said if you have a raised to power 1 over 3 is the same thing as the cube root of a. The cube root of a. If I also have a raised to power minus 1 is the same thing as 1 over a. 1 over a. All right? If I also have a raised to power minus 1 over 2 is the same thing as 1 over a raised to power 1 over 2, which is also equals to 1 over the square root of a. Because raised to power 1 over 2 here symbolize the square root of what? A. So all this is what we're going to use in this solving. For this, we are going to have the cube root of 343 multiplied by, this is going to be 1 over 0.14. 0.14 raised to power minus 1 is going to be 1 over 0.14 following this rule. Multiply by this, we're going to follow this rule. 25 raised to power minus 1 over 2 is 1 over 25 raised to power 1 over 2. So we follow this rule, okay? This rule. What is the cube root of 347? 347. So we are looking for a number that when you multiply it by itself in 3 places, you are going to get 347. So let's try 7 times 7 times 7. That is 49 times 7. And that will give us 343. So the cube root of 343 is what? 7. The cube root is what? 7. So we have the cube root of 343 is 7 times. For this, we have 1 over 0.14 expressed in fraction. Expressed in fraction, we are going to have 1, 2, remove the decimal point 2 times. That is 14 over 100. So 0, 0 symbolize the movement of the decimal points. Remove the decimal point 2 times. That means we are going to have 100. If you move the decimal point 3 times, that means you are going to have 1,000. So for this, we have 100, okay? So this is going to be 14 over 100 multiplied by, this is 1 over the square root. This is 1 over the square root of 25. The square root of 25. So we continue. 7 times 1 over 14 over 100. Let's say we have 1 over A over B. Reciprocation, that is going to lead us to B over A. 1 over A over B will give us B over A. So if you have 1 over 14 over 100, That will be 100 over 14 multiplied by 1 over the square root of 25. The square root of 25 is 5. The square root of 25 is 5. Okay, so let's proceed to do some division. Of course, 5 here is 1, 5 in 100 is 20, and 7 here is 1, 7 here is 2. So we are left with 20 over 2. We are left with 20 over 2. Okay? And 20 over 2 is what? 10. 20 over 2 is 10. So the answer for that evaluation is 10. The answer is 10. Okay? If it is clear to us, please thumbs up or kindly signify with your favorite emoji. If application 3 is clear to us, kindly signify by using your favorite emoji. Waiting so that I can move to the next application. Okay, thank you, Abiodo, for your response. So that implies that we can proceed to the next application. We can proceed to the next application. Okay, so we are going to consider application 4 now. Application 4. So permit me to clean the board. App 4. Okay, let's consider another question. Evaluate log 8 base 2 plus log 16 base 2 minus log 4 base 2. This is UTME question 2014. All right, so we are asked to evaluate this question. We are asked to evaluate this question, UTME 2014. Solution is a question under logarithm. So we have log 8 base 2 plus log 16 base 2 minus log 4 base 2. So we want to evaluate this. Now check the base. You will see that we have identical base, base 2, base 2, base 2, base 2, base 2, base 2. So we need to express our value of log in terms of 2, all right? In terms of 2, which implies that 8 should be expressed in terms of 2. We are going to have 2 raised to power 3, and 16 should be expressed in terms of 2. That is 2 raised to power 4. All right. So 4 expressed in terms of 2 is 2 raised to power 2. So we are going to use all this to substitute the value we have in the question. This is going to give us log 2 raised to power 3 base 2 plus log 2 raised to power 4 base 2 minus log 2 raised to power 2 base 2. So following the law of logarithm or the rules of logarithm, where we have log x raised to power n base b, this comes to the back and we have n log x base b. So the similar thing we have to do to this expression, these guys come to the back. 4 also comes to the back of log, and these 2 also comes to the back of what? Log. So we are going to have 3 log 2 base 2 plus If 4 comes to the back of log, we have 4 log 2 base 2 minus, if 2 comes to the back of log, we have 2 log 2 base 2. All right. So following another rule of logarithm, log y base y equals to 1, log 10 base 10 equals to 1. So which implies that log 2 base 2 will give us 1, 3 in brackets 1 plus 4 log 2 base 2 also will give us 1 minus 2 in brackets log 2 base 2 will also give us 1. So we go ahead to expand the brackets. 3 times 1 is 3 plus 4 times 1 is 4. Okay. Then minus 2 times 1 is minus 2. So we have 7 minus 2, which is equals to 5, which is equals to 5. Subtracting 2 from 7, that will give us 5. So the expression, the evaluation for this question is going to give us 5, following the rule of logarithm. Following the rules of logarithm. Okay, I believe that is clear to us. Kindly signify if application 4 is clear to us. Signify with your emoji, or you can type a message in the chat box. Signify with your emoji if application 4 is clear to you, and you can as well type yes in the chat box that application 4 is clear to me. You can type yes or signify with your favorite emoji. I'm waiting so that we can move to the next application. Then after, we'll take some evaluation questions. I'm waiting. Kindly signify if application 4 is clear to you. Kindly signify with your favorite emoji or thumbs up. Kindly signify, still waiting. Can we proceed to the next application? If yes, thumbs up. And let's move on to application 5. Can we proceed? Okay, all right. Thank you for your response, Abiodun. Let's proceed now to application 5. Application 5. App 5 now. Okay, so let's consider, we've considered a logarithm question. Let's consider another question under indices again. So simplify 3 raised to the power of minus 5n multiplied by 27 raised to the power n plus 1 over 9 raised to the power 1 minus n, UTME question 2013. 2013. So we solve this together. Solution. Okay, so if you are asked to simplify this kind of question, you first need to check what is the smallest base. What is the smallest base? We said earlier when we were doing indices that if you have an expression of a number in this form, a raised to power n, this is called base, and this n is called the power. So in this case, for this question, the smallest base is 3. So I'm going to express other numbers also in base 3. Okay, I'm going to express other number in base 3 because base 3 is the smallest base in this question. So which implies that 27 has to be expressed in base 3. 27 will be 3 raised to power 3, and 9 will be 3 raised to power 2. So we are going to substitute this inside our solution. 3 raised to power minus 5n times 27 now is 3 raised to power 3 in brackets n plus 1. Because we have n plus 1 there before, we are going to put that in brackets, okay? Always put in brackets so that you avoid errors while solving. All right, so we proceed to the denominator. 9 is expressed as 3 raised to power 2. 3 raised to power 2 in brackets 1 minus n. Close the brackets. So what you have to do now is to expand those brackets. 3 raised to power minus 5n times 3 raised to power 3 multiply n is 3n. And again, 3 multiply 1 is plus 3 over 2 multiply 1 is 2, 3 raised to power 2, and 2 multiply minus n is minus 2n. Okay, so now we have similar base in this expression. This is 3, base 3, base 3. So we can go ahead to simplify the solution. So do not forget that we said multiplication in indices changes to addition. Multiplication changes to addition. Okay, so if I have a raised to the power of x multiplied by a raised to the power y, law of indices will be a raised to the power x plus y. So in this case, we have the same base 3 and also base 3. So which implies that we can multiply them together. So if I multiply this times this, I'm going to have 3 raised to power, the power here, minus 5n plus the power at the other side of the base plus 3n plus 3. Okay? I believe we are getting that. Over the denominator, 3 raised to power 2 minus 2n. And also another law of indices states that a raised to power x over a raised to power y is a raised to power x minus y. A raised to power x minus y. So for this expression also, we can go for division, change to minus 3. We have base 3, base 3, base 3, and base 3 here. So I can change my division sign to the minus of the power. Okay, so that will give me 3 raised to power 3 raised to power minus 5n, okay, plus 3n plus 3. Okay, so this division sign now has changed to minus in brackets. What is the power here? The power is 2 minus 2n, close the brackets. So we need to simplify this. Minus 5n, okay, plus 3n, plus 3n, plus 3. Now use minus to open the brackets. Minus times 2 is minus 2. Minus times minus is plus. So we have plus 2n. plus 2n. Okay, so we can actually do some simple arithmetic here. This is minus 5n. If I add up this guy to this guy, I'm going to have 5n. Okay, I'm going to have 5n. So that means I'm going to have 3 raised to power minus 5n plus 5n. Okay, then we have subtract these 2 from these 3. The answer is plus 1. The answer is plus 1. Okay, so if minus 5n cancel out plus 5n, if minus 5n cancel out plus 5n, this cancel out this. So we are left with 1 alone. So that means the answer will be 3 raised to power 1, which is also equals to what? 3. Okay, which is also equals to 3. That means the final answer is 3. For this expression, simplify this question, our answer will be what? 3. Because minus 5n plus 5n has cancelled each other, and what we are left with is 1. 3 raised to power 1 is also 3. 3 raised to power 1 is also 3. Okay? If application 5 is clear to us, please kindly signify. Signify with your emoji, or you can type in the chat box, yes, I understood application 5. I'm waiting for a response so we can move to the last application. Then after we go to evaluation. We have one more application to take. Is application 5 clear to us? I'm waiting. Waiting for your response. Is application 5 clear to us? If yes, thumbs up. So move on to application 6. Waiting for your response. If you're online and you are following me, if application 5 is clear to you, thumbs up. If you have any question based on this also, do well to signify and drop your question in the chat box. I believe we can proceed, right? Can we proceed to the next application? If yes, thumbs up, thumbs up, thumbs up, thumbs up, so that we can move to application 6. Still waiting? Can we move on to application 6? All right. So I believe we can move on to the next application, which is application 6, right? Okay, so permit me to clean the board to rub off what we have on the screen on the board so we can move to application 6. App 6, we're going to consider a second question under solved. A second question under solved. So let's consider this question under solved. Rationalize 1/3 minus 6 1 over 3 minus 6. Rationalize this. UTME question 2013. Okay, so we are asked to rationalize this question. And to rationalize, you first need to understand what conjugate is. We discussed about conjugate yesterday. I said if I have 1 plus root a, the conjugate is 1 minus root a. And if I also have root a plus root b, the conjugate is root a minus root b. So if you have to rationalize, you have to multiply the numerator and the denominator by the conjugate of the denominator. So we first have to get the conjugate of 3 minus root 6, and that is 3 plus root 6. The conjugate of 3 minus root 6 is 3 plus root 6. Okay, so now let's proceed. 1 over 3 minus root 6. Multiply both the numerator and the denominator by the conjugate, which is 3 plus root 6 over 3 plus root 6. Okay, so with this, we proceed to multiply. Multiplication, 1 in brackets 3 plus root 6, close bracket, over, open bracket 3 minus root 6, another bracket 3 plus root 6, close the bracket. So when we proceed to simplify this, 1 times this bracket will still give us the bracket again. So that is 3 plus root 6 over. Now this expression here reminds us of what we call difference of two squares. Okay, if I have a square minus b square, it is equals to a plus b and a minus b. So this is what we call difference of two squares. So exactly this expression here, if this stands for a, and this is b, this is a and this is b. So that means we also have difference of two squares. So I'll take 3. This will be 3. This is root 6. This is 3. This is root 6. So which implies that what I'm going to have here is 3 squared minus, open bracket, root 6 all squared. Okay, root 6 all squared. So I've expressed this in form of difference of two squared. Difference of two squared. Instead of us to multiply out the bracket, that will take time. So we can just relate it to what we call difference of two squared. So that's going to give us 3 squared minus, open bracket, root 6, close bracket, square. So what we have here is equivalent to what we have at the denominator here. So proceed. We have 3 plus root 6 over 3 squared is going to give us 9 minus root 6 squared. Root 6 all square. The square cancel the square root. So we have 6. So the value here will be what? 6. We proceed. That is 3 plus root 6 over, all right, over what? Subtract 3, subtract 6 from 9, subtract 6 from 9, you have the answer to be 3. So the final response will be 3 plus root 6 over 3. Okay, 3 plus root 6 over 3. That will be the final answer for this question. Rationalize this expression. After rationalizing that expression, we got this response, 3 plus root 6 over 3. Okay, so this is going to be the last application. We've treated 2 applications on logarithm, 2 applications on indices, and 2 applications on sort. Okay, so I believe the last application we did, which is application 6, is clear to us. So if it's clear to us, please kindly signify with thumbs up. or drop a message in the chat box. And also, if you have a question, kindly drop it in the chat box, and we are going to treat it together. We have few minutes to go. If application 6 is clear to you, kindly signify. Waiting for your response so we can move to the evaluation period. I want to be sure that application 6 is clear to us. Thumbs up if application 6 is clear to you. All right, so we can proceed to the evaluation period now. Okay, so permit me to rub off the board. Evaluation, just have like 1 or 2 questions to ask us. Evaluation. Okay, so evaluation, simplify 56a raised to power minus 6 over 7a raised to power minus 4. So that is for us. We have to simplify that question. So I'll be waiting for your response in the chat box. Simplify this expression. I'm waiting. Any response? Simplify this expression. Okay, if I'm going to simplify this, let's do it together. 56 divided by 7 times a raised to power minus 6 over a raised to power minus 4. When you divide 56 by 7, that should give us 8 times the law of indices, division change to minus. So I have a raised to power minus 6 minus, which is the natural minus, into bracket minus 4. And that will give me 8 times a raised to power minus 6 plus 4. And that is 8 times a raised to power minus 2, which is 8a raised to power minus 2. 8a raised to power minus 2, or 8 over a square. 8 over a square. So this is also correct, and as well this is also correct. So that will be our response. That will be our response. So the second question, what is the conjugate? What is the conjugate? What is the conjugate of root 3 plus root 5? The conjugate of root 3 plus root 5. The conjugate of root 3 plus root 5. I'm waiting for your response in the chat box. Waiting for your response in the chat box. Okay. All right. Okay. We have response root 3 minus root 3 minus root 5. Yes. Root 3 minus root 5. That will be the conjugate of root 3 plus root 5. That will be the conjugate of root 3 plus root 5. The conjugate is going to be root 3 minus root 5. Root 3 minus root 5. Okay, so we are going to stop here today. And today we have been able to cover up applications, that is solving UTME questions on indices, on logarithm, and Surd. Okay, we're able to solve 6 questions on those topics. We're able to solve 6 UTME questions. And in the previous class, we've already discussed about the laws of indices. So I will urge us, if you need more details video, do well to visit the A1 Tutor app and check for the topic indices or check for logarithm or sort and watch a detailed video. Do well also to practice question using the CBT session of the A1 Tutor app, practice question on mathematics related to this topic, which is indices, logarithm, and sort. And perhaps if some of your colleagues were unable to join today's live session, tell them not to panic. All they need to do is to visit A1 Tutor on YouTube channel, A1 Tutor A1 Tutor on YouTube channel and watch the videos for today's class and also for the previous class that we have taken for all subjects. Okay, do not just watch, also ensure that you share, you like, you comment, and also you subscribe to the channel. Thank you. See you tomorrow. Tomorrow is another time. We'll be taking another topic entirely. Ciao. Bye bye for now. See you tomorrow.